All right. Good morning, good afternoon, good evening, good night, whenever you're watching this. I hope you are well. I'm going to go ahead and start with a bit of updates and then we will jump into our topics for today. So, just a real quick reminder, we do have our second assessment in class in online. The one thing I do want to talk about is what the format or the platform should look like. So if you look at this scholar here, notice that I can see the scholar's workspace, and it is a closed book, so you shouldn't have a book open. You are allowed to have a calculator for the assessment, but for the most part, I should be able to see your workspace. That means that you probably will have to have two devices. You'll get on Zoom with both. One will be on your computer, and then the other will be like a phone or a tablet where I can see your workspace. So please make sure you figure that out before our next class. All right. So I'm going to jump in right into it. On today, we talked about 1.5 in quadratic equations. As promised, I said that I would do one more type of problem that you may see on the assessment in reference to quadratics. So it says, write an equation in terms of x that represent the given relationship. Solve the equation to find the dimensions of the given shape. So they tell us that we have a rectangle. It says the length of the rectangle is 3 yards more than twice the width. The area is 620 yards, 29 yards squared. So one thing to keep in mind is that you have a rectangle. So that's the first thing. And then the second thing, get my pen going. Oh, there it is. So we have a rectangle. And the area for a rectangle is always length times width. So it tells me that the length is 3 yards more than twice the width. So the length is 2x plus 3, so 2 times more than 3 yards more than twice the width. So 2 times the width plus 3. The width is going to be x because we don't know what it is. So if we're looking at this equation, it tells us that we're doing area equals length times width. So I'm going to say the length is 2x plus 3. And the width is x. And the area is 629, which they gave us. So we're going to solve, we're going to distribute this x to everything. This gives us 2x squared plus 3x equals 629. So remember, whenever we're working with quadratics, we always want to make it equal to 0. So we're going to subtract 629 from both sides. And I have 2x squared plus 3x minus 629 equals 0. So now I have to solve. I need factors of 2 times 629. That's going to give me 3. So I can do 2 times 6, negative 629. That gives me negative 1258. And then I know 1 times 1258 will give me 1258. 2 times 629, I know that one because of what I multiplied here in the beginning. And then I'm going to jump a little bit. 17 times 74. And then the next one is 34 times 37. So this is the one that I want to work with because I can make this equal positive 3 by making the 34 negative. And then we're going to factor by grouping. So 2x squared and then the negative 629 I'm putting on the end. I'm going to expand the middle. I'm going to say negative 37x. Positive 37x minus 34x. And then remember, this is interchangeable, so you could have put the 34 in the front, and you would still get the same answer after you factor. So I see that I have a polynomial here, so I'm going to factor here in x, and that leaves me with 2x plus 37. And then here I can factor out a negative 17. And that also is going to leave me with 2x plus 37. And this all equals 0. So I have two factors. This on the outside, x minus 17, set it equal to 0, and then 2x plus 37, set that equal to 0. So when I add 17 to both sides, I get x is 17. And when I subtract 37 from both sides, I get 2x equals negative 37. And when I divide it by 2, I get x equals negative 37 over 2. So we're not going to use this one because we know we can't use a negative length. So they want to know how to solve the equation and get the dimensions. So I know that the width is 17. And then the length is going to be 2 times 17, which gives us 34 plus 3. So the length is 37. All right. So if you have any questions, again, you can ask when we meet again. All right, so I'm moving in 3, 2, 1. All right, so our next thing is 1.6, more equations and applications. So here it says solve a polynomial equation at 4x cubed plus 12x to the second minus 9x minus 27. Whenever I see four terms, I know that I can group them. So that's what I'm going to do here. I'm going to group the first two and then the second two. And then I'm going to factor here. I can factor out a 4x squared. So remember, you're taking out the smallest x. That leaves me with x plus 3. And then here I'm factoring out a negative 9. And that also leaves me with x plus 3. So my factors are 4x squared minus 9. We're setting that equal to 0. And x plus 3. And we're setting that equal to 0. So what are my solutions? First thing I'm going to do is add 9 to both sides. I get 4x squared equals a positive 9. Then I'm going to divide by 4. I get x squared equals 9/4. Today we learned that whenever we have a square, we take the square root of both sides and we get a plus or minus. Square root of 9 is 3. Square root of 4 is 2. So plus or minus 3/2. Then I'm going to do the next one. I'm going to subtract 3 from both sides, and x is equal to negative 3. So one thing about this is that whenever you're solving these type of problems, the exponent kind of tells you how many solutions you're going to get. So if it's a 3 and it's a polynomial, you're going to get 3 answers. So for example, here we have positive 3/2, negative 3/2, and negative 3. All right, let's try another one. So I'm going to have you pause the video and then try this one. All right, so you should have gotten these three answers: negative 4, 1/5, and negative 1/5. Okay, what about when we have a scenario like this? So here we can't just square root, so we're going to make sure that this equals 0. The way that I'm going to do that is I'm going to subtract 16x squared from both sides. That leaves me with 2x to the 5th minus 16x squared equals 0. And then I can factor. So with 16 and 2, I can factor out a 2. X to the 5th and x squared, I can factor out x squared. That leaves me with x to the 3rd minus, what can I divide here? I'm going to get minus 8 equals 0. First part's easy. I can just take the 2x squared, set it equal to 0, divide by 2, x squared equals 0. You don't have a plus or minus 0. It's just 0. So this is one of my solutions. Now I'm going to look at the next part. This is a cube or the difference of cubes. So we can use our formula. So x cubed is a perfect cube. 8 is also a perfect cube. So I'm gonna solve this part. I'm gonna have x minus 2 because the cube root of x cubed is x. The cube root of 8 is 2. Then I'm gonna have x squared plus 2x plus 4. So I see, and again, this all equals 0. I see the x minus 2. I can set that equal to 0. Add 2 to both sides. I get x equals positive 2. Here, there's no factors of 4 that's going to give me 2. So I have to use a quadratic formula, right? So I'm going to identify A, B, C. A is 1, B is 2, C is 4. Opposite of B is negative 2 plus or minus B squared, so 2 squared, minus 4 times A, which is 1, C, which is 4, all over 2 times A, which is 1. So that's step number 1. Going to continue. I get negative 2 plus or minus 4 minus 16 over 2 because negative 4 times 1 is negative 4 times 4 is negative 16. I get a negative 2 plus or minus the square root of negative 12 all over 2. And then I want to simplify a little bit more. So here x equals negative 2 plus or minus. I know that I can break up 12 to negative 4 times 3 all over 2. So that's going to give me x equals negative 2 plus or minus 2y root 3 all over 2. And then my final answer is negative 1 because negative 2 divided by 2 is negative 1 plus or minus I root 3. So remember what I told you in the previous problem? If you have the exponent here was 5, so we're going to have 5 solutions. So we have 2 here, 3, and then because we took a square root, this is considered 2 here. So 2, 3, 4, 5. Okay? All right. Now we're moving on to solving rational equations. We kind of did this before, but this is different because you have to do a little bit more factoring. So I have 2x minus a 4 minus a 3x over x plus 2, and then something happening over here. So I'm going to first find factors of negative 8 to add up to negative 2, 1 and 8, 2 and 4. I'm going to use these two, and the 4 is going to be negative. So this factor right here is x plus 2 and x minus 4. So this first term here has an x minus 4. This one has an x plus 2. This one has both of them. So my common denominator here is x plus 2 times x minus 4. Remember what we did in the past? We multiplied everything by x plus 2, x minus 4, or the common denominator. So x plus 2, x minus 4 times 2x over x minus 4. And then x plus 2, we have a minus here. So x plus 2 times x minus 4. And we're multiplying that by 3 over x plus 2. And then one more time, x plus 2 times x minus 4 over times x squared plus 14. All of that is over x squared minus 2x minus 8. All right, so now we need to start to cancel. And so I'm going to cross out here x minus 4, here x plus 2, here both of these because the bottom is equivalent to x plus 2x minus 4. That leaves me with 2x times x plus 2, negative 3 times x minus 4 equals x squared plus 14. So we're going to distribute 2x squared plus 4x minus 3x plus 12 equals x squared plus 14. I'm going to first combine like terms, so I can combine these two. 2x squared plus x plus 12 equals x squared plus 14. Remember, we always want this to equal 0, so we're going to move everything to the left. I'm going to subtract x squared and 14. 2x squared minus 1x squared is 1x squared plus x, and then 12 minus 14 is negative 2. Now we need to factor. I need factors of negative 2 this time that add up to 1. So 1 times 2, I needed to add up to 1, so this one's going to be negative. So I have two factors, x minus 1 and x plus 2 equals 0. And then we solve. So x minus 1 equals 0. X plus 2 equals 0. You solve. X is 1. And x is negative 2. So you always want to check. Remember, we don't want the denominator to be 0. When I plug in 1 here, it works. 1 minus 4, that doesn't give me 0. Excuse me, and 1 plus 2 does not give me 0. When I plug in negative 2, it works here. Negative 2 minus 4 is negative 6. Negative 2 plus 2 is 0. So this one is a problem. So my only answer here is going to be x equals 1. All right. All right, pause the video. Try this one on your own. And you will get two solutions when you solve x equals 5 and x equals negative 6. But when you plug 5 in here, it makes the denominator 0, which doesn't check out. Moving on to solving absolute value. So whenever I'm talking about absolute value, I always like to talk about distance because that's what it is. And so I like to talk about living at a home. So I live at house number 0. And if I ask you who lives 5 units away, you have people to the left of you that live 5 units away, and then you have people to the right that live 5 units away. So when you're talking about distance, you have to do the left and the right. All right. So here, absolute value of u is equals k. You're going to get u equals k and u equals negative k. So that's going to the left and right. If you have u, absolute value of u equals 0, u is going to be 0. The one issue that you're going to have is if you ever get the absolute value of something equal a negative, it's going to be no solution because you can't go negative distance. All right. So let's look at some examples. So for the first one, you got to think of it first as if it is a regular equation, but then we're talking about distance. So we have 2, right here, 2 times the absolute value of 3 minus 2t equals 6. First thing we're going to do here is we're going to divide both sides by 2. We have the absolute value of 3 minus 2t equals 3. So I want to know who lives 3 units away from 3 minus 2t. So I know that I'm going to have some people at 3 minus 2t equals 3. I'm also going to have some people to the left. So 3 minus 2t equals negative 3. And I'm going to solve both equations. So here I'm going to subtract 3, negative 2t equals 0, divide by negative 2, t is 0. Same thing on the right-hand side. We're going to subtract 3, negative 2, 3, t equals negative 6, divide by 2, negative 2, and t equals positive 3. Okay, so these are your solutions for the first equation. Now let's look at B. I have 2 equals the absolute value of 7w minus 3 plus 8. So first thing we want to do is we want to subtract 8 from both sides. We get -6 equals the absolute value of 7w minus 3. So this is asking who lives -6 units away. So for this question, you're going to say no solution. Or you can just write an empty set like this. All right. Okay, pause the video, try these two. You should get -2, 3 for the first. And the second one, when you subtract 9 from both sides, you get -4, which is not going to work. Next, we're solving radical equations. So here you want to leave the radical alone and move everything away from it. So if that's the case, I am going to add 4 to both sides. I get the square root of x plus 10 equals x plus 4. So we want to undo this square root on the left side. So remember, to undo a square root, you square it. So when we undo that, we get x plus 10 on the left side. On the right side, we have to FOIL. So x plus 4 times x plus 4, right? That's x squared plus 4x plus 4x plus 16. And then we're going to combine like terms, x squared plus 8x plus 16. Remember, we want it to equal 0, so we're going to solve. We're going to subtract 10 and x from both sides. So 0 equals x squared plus 7x plus 6. Next, we're going to factor. We need factors of 6 that add up to 7. So we have 1 and 6, 2 and 3. We're using 1 and 6. So x plus 1 and x plus 6 equals 0. So we're solving for x. X plus 1 equals 0. Subtract 1. X is -1. That's one solution. And then same thing for x plus 6 equals 0. Subtract 6. X is -6. So you always want to check and make sure that it works out, because sometimes you get what we call extraneous solutions, which mean it doesn't work. So I'm going to plug this back into my original equation. I'll do -1 first. So -1 plus 10 minus 4 should equal -1. -1 plus 10 is 9. Minus 4 should equal -1. Square root of 9 is 3. 3 minus 4 does equal -1. So this one checks out. Now I'm going to do the same thing for -6 and make sure that one works. So I'm going to do square root of -6 plus 10 minus 4 equals -6. Square root of -6 plus 10 gives me the square root of 4 minus 4 equals -6. Square root of 4 is 2. 2 minus 4 does not equal -6. So this one is not a true solution. All right, so make sure you check. Okay, so try this one, pause the video. Should have gotten 9 for your solution, because the 2, when you plug it back in, does not work. All right, moving on to 1.7, which is linear, compound, and absolute value inequalities. So we're going to start off with basic inequalities. When we solve for x, and we get x equals -4, that means x is one exact value. When you have x plus 4 is greater than 0, when you solve, you're looking for points that are greater than -4. When you solve here, you're looking for points that are less than -4. Now, there are some things that I want to point out here. First thing is look at the inequality here. It is greater than or equal to, which means you have to follow through with the notations that you're using. So the first set of notations is called set builder notation, where you're just using an inequality. Set builder notation. I'll just write notations up here. And the second one is interval notation. All right, so they might ask you to do both or one. Just think that set builder notation is whatever you get whenever you solve. Interval, you have to talk about what it covers. So for example, here you're going from -4 to infinity. From here, you're coming from -infinity to 4. You always read it from left to right. So let's look at our first example. It says solve the inequality, graph the solution set, and write the solution set in set builder notation and interval notation. All right, so let's solve. We're going to subtract 4 from both sides. That's step number 1. We get -6x is less than 30. Whenever you divide or multiply by a negative, you must flip the inequality. So I get x, 30 divided by -6 is -5. So they said to graph it. So if I'm graphing this, I'm at -5. One trick, as long as the x is on the left-hand side, you can draw a line in the inequality. It tells you which direction to go in. So if it is less than or greater than, you're using parentheses. If it's less than or equal to or greater than or equal to, you're using brackets. So if you go back to the previous problem, you can see here we had a greater than or equal to, they used a bracket. Here we had a less than, they used a parentheses. All right, so let's continue. We're going to have a parentheses at 5, and we are going to the right. Okay, so we have to write it in set builder notation. Set builder notation is just going to be, and I'm just going to write SB. You're going to write a bracket x such that x is greater than -5. You're done. If you're doing interval notation, you're going to say that we're going from -5, and it continues all the way to positive infinity. All right. Okay, try this one. Pause the video. So they ask you to do a set builder notation, interval notation, and then this graph has a bracket. You had to flip the inequality because you were dividing by a negative. So whenever you divide or multiply by a negative, you must flip the inequality. Compound inequality. So sometimes you'll have two inequalities when you ever see, or usually they're going in opposite directions. So for this first one, I have x minus 2 is less than or equal to 5. I'm adding 2 to both sides. I get x is less than or equal to 7. Here, this is division on the left-hand side. The 1/2 x is greater than 6, so we're going to multiply both sides by 2. This cancels it out, and then we have x is greater than 12. So what does this look like on a number line? You have a 7, 8, 9, 10, 11, 12. And then at 7, I'm going to the left, and I have a bracket, so my graph looks like this. At 12, I'm going to the right, and I have a parentheses, so I'm going this way. So that's what an OR example would look like. Try this one. Pause the video. You should have gotten for set builder notation, y is less than or equal to 4, or y is greater than or equal to 2. And then for the inequality, the interval notation, we did -4, negative infinity to -4, and 2 to 8. I'm not sure if I did that on a previous problem. I did not, but it didn't ask to do it, but I will show you what it looks like if you're writing it in both set builder notation and interval notation. So for set set builder notation, you have 2, so you're going to say x such that x is less than or equal to 7, or x such that x is greater than 12. For interval notation, you're saying from negative infinity to 7 with a bracket, and, or rather, from 12 with the parentheses to infinity. All right, so that's what it looks like. Then back to this. And then on to the next example. So the next example is asking you to solve a compound inequality that has an and. So here you're going to multiply for the first one, both sides times -4. And remember, anytime you're multiplying or dividing by a negative, you have to flip the inequality. So you get t is greater than -8. For this right side, I have 0.52t. It's greater than or equal to 1.3. So we're going to divide both sides by 0.52. And I get t is, I don't have to flip the sign, greater than or equal to 2.5. So as you can see, this graph kind of overlaps. There's 2 ways that you can see this. You can see it where it's broken down into 2 graphs. So you have the t equals negative is greater than -8. And then the t is greater than or equal to 2.5. Notice this one has a bracket. This is a parentheses. The one on the bottom only focuses on the one where they overlap. Excuse me. So wherever they overlap, you can graph that on one graph. All right. Okay, try this one. Pause the video. Okay, this is what your graph should look like, or actually your solution. So W such that W is less than -6. And then if you're talking about interval notation, from negative infinity to -6. So again, I'll go back. I don't believe I did that here. So you can say T such that T is greater than or equal to 2.5. Or you can say from 2.5 to infinity for interval notation. All right. All right. Next is a 3-part. If you have 5 is less than -2x plus 7, which is less than 11, first thing you want to do is subtract 7 from both sides. 5 minus 7 is -2. -2x is less than or equal to 11 minus 7, which is 4. Then if you were to cover this part over here, you would have -2x equals 4 or less than equal to 4. So you're going to divide just like you would a regular equation. And as you can see, we are divided by a negative, so all the signs are going to change. -2 divided by 2, -2 is +1. Flip the sign. X, flip the sign, -2. So now part of the problem is if we try to graph this is a little backwards because -2 comes before 1. So for these type of problems, if I need to graph, I usually just flip it so that I have -2 first, the 1 here, X stays in the middle, and then the signs change. So we have less than over here with the 1, and then less than or equal to with the -2 and the X. So be careful, keep the signs the same. And if you're writing this in set builder notation, X such that you're between -2 and 1. Or you can say for interval notation, you're going from -2 with the bracket to 1 with the parentheses. All right. Try this one. Pause the video. Here's your solution. All right, we're moving on to absolute value when we're solving inequalities. So for this question is as very similar to regular inequalities when you have equal sign. Remember, it cannot equal a negative. So, and it can't be less than or greater than a negative either. First thing I'm going to do is add 3 to both sides. I get 2 times the absolute value of 6 minus m is less than 10. So who lives less than 10 units away? So people that live less than 10 units away are going to be like numbers 9, 8, 7, 6, right? That's how you got to kind of think about it. So I'm going to divide both sides by 2. Absolute value of 6 minus m is less than 5. And then whenever we get here, we want to put the 5 on both sides. So we're going to have negative 5 is less than or equal to less than 6 minus m, absolute value, and less than 5. All right, and then we want to continue to solve. So first thing we're going to do is we're going to subtract 6 from both sides. You get negative 11. And then you get negative m here. And then you get negative 1. We want to continue. We want to divide by negative 1 on both sides. And then we get negative divided by a negative is a positive. And then remember, whenever you're dividing by a negative, you must flip the sign. So 11m positive 1. All right, so if we want to flip this so that it is going in numerical order, we're going from 1 to m to 11. And how do we write this in set builder notation and interval notation? For set builder notation, you're going to have, we're talking about m, so m such that 1 is less than m, less than 11. And for interval notation, we're going to say from 1 to 11, parentheses on both sides. All right. Try this one. All right, so you should have ended up with brackets, and this is going from 1 to 9. All right, so that's all I got. Please come with your questions when I see you tomorrow. Have an amazing evening, day, or morning whenever you're watching this, and I'll see you soon. Take care. Be safe.